All right, perfect. Hi everyone. My name is Liza Goldberg. I'm really excited to be with you today and speak to you about how we can use satellite imagery to monitor global environmental change. So I'll just jump right into it. If my PowerPoint decides to advance. Great. So just to introduce myself, again, my name is Liza Goldberg. I'm a first-year student at Stanford University out in Palo Alto in California. And I've been working as a biospheric scientist at NASA Goddard Space Flight Center for the last 5 years or so. And most of my work at NASA has surrounded using various kinds of satellite imagery to monitor global coastal ecosystem vulnerability, specifically with mangrove ecosystems around the world. But unfortunately, as I've continued my work for NASA, I've found that although I've been able to get a decent understanding of the extent of global environmental change and how it's impacting populations around the world, I found that other students that I've been in classes with and the public don't actually share the same level of understanding. When we look in the news, we constantly see headlines like this from the New York Times, or like this one from The Guardian, or like this from the Washington Post. And when we put all of these headlines together on a weekly, monthly, and yearly scale, we see we have a pretty clear consensus here. We should be alarmed. But why is it that we aren't alarmed? Why is it that we see these headlines and understand the extent of what's going on statistically with climate change, and somehow we still don't necessarily view climate change as something that's going to impact us either now or far into the future and in future generations? At least in my eyes, I think a lot of this comes down to the fact that with these headlines, although we can see the numbers and understand the statistics, we can't actually visually see and therefore tangibly understand what's going on. But in my opinion, there's a pretty clear solution to this, and it's satellite imagery. Using satellite imagery, we're able to capture global environmental trends like deforestation, as you'll see in this video in a minute. Once it loads. Perhaps this video is not deciding to load, but perhaps we can try and move to the next one. Sorry, everyone, for the internet issues. Perfect. So here in this video, you can see a time lapse of Great Salt Lake in Utah as it shrinks over the last several decades or so. And this is a combination of factors due to overuse of water for irrigation throughout the Great Plains region, and also overuse on the urban side of things in cities near this lake. We're also able to capture other global scale trends like global ice melts, which I'll show in the next slide. Once it loads again. So here you can see the iconic Columbia Glacier in Alaska as it shrinks over the last 2 decades or so. And so again, using satellites, we're able to capture this trend from space from a different perspective. So what I think is so valuable about these videos is that it really, puts people in the exact environment that we're focusing on, where we're seeing the extreme climatic change. So you don't actually just view these changes through the lens of numbers and statistics in news articles. Satellite imagery actually enables you to visually see these trends and better understand different patterns in terms of how global environmental change is impacting both your local community and also communities across the world. But then the question becomes, how can we actually capture and quantify these changes? Given what we know about how to actually capture these satellite imagery based trends visually, we now need to go in and actually say, okay, how do we quantify this? To what extent are we seeing forest change? What are the numbers? What is the total area of ice that we're seeing melt throughout Greenland and the Arctic? Just seeing these visual changes is not necessarily enough in all circumstances. So the best solution, I think, to this particular question is a program called Google Earth Engine. So you can think of Google Earth Engine as kind of like the back end of Google Earth. It's where we're able to actually access all of the satellite imagery that you see in Google Earth or Google Maps. And then using those satellite data sets to actually start to process them within the cloud. And then use JavaScript analysis to actually create viable applications that can be shown to the world and aid the scientific community. So what actually is Earth Engine behind the scenes? So Earth Engine can be divided really into 4 parts. So first, pretty exhaustive catalogs of data sets. So with Google Earth Engine, you're able to access all sorts of data sets from things like multispectral data, radar and aerial data, climatic data. So looking at things like precipitation and temperature over time, and also other data sets like land cover and vector or shape-based data sets. What you're then able to do is actually store all of these data sets on Google servers. So you don't have to store any of these kind of very large scale data sets on your own local machine. All of those data are actually just stored on Google's end of things, so you don't have to worry about it. What you're then able to do is take those data sets and then use a JavaScript API or application programming interface, which is just kind of an online way of coding without actually downloading any coding software. And you're able to use JavaScript to actually process these different data sets in the cloud, which I'll show you a little bit later. And then again, using this browser IDE, you don't need to download anything or pay for any kind of software. It's all just hosted in a cloud-based environment. So I did mention these pretty exhaustive data catalogs within Earth Engine. So in this graphic, you're seeing the Google Earth Engine data catalog, which I link at the bottom here. It's at developers.google.com, and then Earth Engine datasets. And then just to kind of give a preview of a couple of the different data sets that Earth Engine is quite well known for. I'm sure many of you are familiar with the Landsat program. So Landsat was a series of satellites that was first launched in 1972 by NASA, the US space agency. And then since then, every couple of years, NASA has continued to release these different satellites up into the present day. And we're actually looking forward to Landsat 9 and Landsat 10 being launched in the coming years. So using Landsat, what we're able to do is go all the way back in time to 1972 and really see these sorts of true color images, as you can see in the background here, that help you actually visualize and analyze how Earth's surface is changing over time. We're also able to look at things like temperature-based data sets. So using Earth Engine, we're able to catalog temperature changes all the way back from 1950 to the present day. And what this really enables us to do is start analyzing climatic trends from the local to the global scale and understand how things like climate change are impacting temperature trends and hotspots of heat. What we're also able to now do is use Earth Engine to access things like high resolution imagery. So we can go down all the way to the 3 to 5 meter scale to look at really small scale changes that might be happening on the plantation scale or the smallholder farmer scale. A lot of these high res imagery applications are within agriculture. But as you can see in this background imagery here, it can also be used to analyze changes in things like city environments to help us better understand how climate change and other global environmental changes are impacting populations in cities around the world. We're also able to analyze a whole suite of other climate-based data sets. So the data set that you're looking at in the background here is a projection-based data set that looks at the RCP projections for precipitation over time. So again, with precipitation, we're able to go all the way back to 1950 and then project it over the next century as well. So we can not only look at the historical side of the data sets, but also project that forward all the way to decades and decades into the future for climate modeling purposes. And then finally, Earth Engine has a whole suite of other types of data sets as well. So things like terrain data that help us understand the elevation and dynamics of things like rivers and mountains. So just as another kind of really quick, simple overview of how this works, we take these satellite-based data sets that I just showed you, we apply your algorithms to them using JavaScript coding, and then using your algorithms, you can create real-world applications both in the scientific community and also for other things like humanitarian purposes. So just to go over what a couple of these potential applications actually look like. Here you're seeing really the most iconic application of Google Earth Engine. It's a program called Global Forest Watch. And this program was launched in the early 2000s by a team at University of Maryland in collaboration with Google. And what they were actually able to do is catalog the extent of all forest change, so both forest gains and forest losses at the global scale, all the way down to 30-meter resolution over the last 2 decades or so. And what this really enabled us to do is create a level of transparency in terms of deforestation monitoring that was really unprecedented. Now we're able to actually track things like local illegal logging in the Amazon, for example, or small cutting of forests in East and West Africa, and then actually communicate that information to lawmakers and stakeholders at the global scale to help prevent these sorts of forest disturbances from continuing to occur in the future. Ultimately, Global Forest Watch relied on several million Landsat images that were all processed within Earth Engine. So what this really shows is that Earth Engine is meant for these sorts of global scale analyses that were really not possible before. Another really interesting application of Google Earth Engine is something called Global Fishing Watch. All of the small dots that you're seeing here are fishing vessels that you're seeing over the last 12 months or so. And what the Global Fishing Watch team did was actually use radar data within Earth Engine to track the location of both legal and illegal fishing vessels in international waters. And what this also does is create another level of transparency on the high seas to enable governments to actually process, where are these illegal fishing vessels actually fishing, and how can we kind of stop their paths and prevent them from traveling into things like conservation areas and marine protected areas in the future. As a third application of Earth Engine, there are a whole suite of other more local scale applications as well, looking at different climatic changes, like the extent of surface water change over time. So what this particular application is showing is changes in water occurrence from 1984 to 2018. So you're able to get down to the hyperlocal scale. Here you're seeing the Aral Sea, and better understand these changes locally to globally. And analyze how these sorts of local patterns might repeat themselves elsewhere in the world. So how do we actually, get down and start creating these sorts of applications? So within Earth Engine here, what you're seeing here is the coding interface. So there are a couple of parts of this that I can just briefly introduce you to. On the left here, where I'm kind of circling my mouse, this is the Scripts tab, where you're able to keep track kind of like a file folder of all of your coding scripts that you're processing. Here in the center, where you see this code, this is where you're actually able to process these different satellite-based data sets. You can print information about these data sets on the right here, and then also visualize these maps that you're coding from the code that you see on the top here in JavaScript in the cloud. But there's a big problem here, and it's that not everyone actually is familiar with this style of coding and with remote sensing in general. And so, as I was working within Google Earth Engine through my work at NASA over the last several years, I realized, we should have a way to actually communicate these sorts of analyses that we're creating to the public and to those outside of the scientific community who are not familiar with how to actually do these analysis, but still want to get access to these data and understand how these global environmental trends are impacting local communities. So as a result, several years ago, I launched a program called Cloud to Classroom. And really the purpose of Cloud to Classroom is to bring these satellite-based data sets to K-12 classrooms across the world and young people and educators in the public as well. So with Cloud to Classroom, just to kind of go over a couple brief overviews of what this actually means. What we've done is use the Google Earth Engine backend to code a series of satellite-based apps. So what I mean by this is using Earth Engine, we're able to actually access all of these satellite-based data sets that I mentioned before, and then communicate the analyses that we're seeing through publicly available apps that enable the public to actually access the visualizations for these satellite-based data sets without actually coding them at all. And then the third stage of this Cloud to Classroom project is actually integrating these satellite-based applications into classrooms around the world. And we've specifically focused on K-12 classrooms, but this is also applicable to universities as well. So just to give a quick overview of the extent of this project so far, We've trained about 500 students and teachers, both in person and online. Unfortunately, over the last year, all of our trainings have been online due to COVID, but we're definitely looking forward to moving to in-person training soon. And then I will have an opportunity at the end of this presentation to kind of send a note to me and to the Google team if you want to request an in-person training at your institution later this summer, or an online training as well. So far, we've developed 18 different online web apps that allow students and teachers to actually access all of these different satellite-based data sets. We've developed 10 supplementary curriculums to accompany these online web apps that allow teachers and students to more easily integrate these different supplementary curriculums into classrooms, specifically in biology and earth sciences. And then we currently have 7 more current event-based web apps currently in development that we're working on. So here, really, the goal is to target each one of these apps that we're creating towards the Sustainable Development Goals. So here you can see 7 goals that we've specifically targeted so far, everything from clean water and sanitation to climate action, life on land, and sustainable cities. And really, each one of our apps typically accomplishes or addresses multiple goals in terms of trying to see how we can monitor these different indicators and see how we're moving forward, or the opposite as well, how we're not achieving various goals and indicators associated with those goals from the local to the national and international scale. So to start with, focusing on a lot of our long-term climatic trend apps. So far, we've built 6 main apps within the category of long-term environmental changes. So we have a sea surface temperature app, an urbanization app, an app looking at drought, both globally and on the local scale, and also looking at things like ice melt, extreme weather, and human influence. So just to kind of give an introduction to a couple of these apps that I wanted to showcase, I want to start each introduction to an app with really the line in one of my high school textbooks that inspired the creation of this particular app, to demonstrate really the fact that we're going from just these simple statistics to a more global scale visualization that more tangibly helps students actually understand how these sorts of global environmental trends are impacting different communities. So to start with this first quote from the textbook, it says, "Large areas of severe or extreme drought affected every continent except North America in 2017. And it goes on to describe some specific hotspots, specifically in Africa and southwestern India, where we're seeing droughts as a kind of hotspot issue. So after seeing this particular quote from the textbook, I wanted to see how we could potentially translate this to an application using satellite imagery. So the result, sorry, did someone say something? No? Okay. So what you're seeing here is a demonstration of our global drought monitoring app. So you can see changes over time in the slider on the left, as we can see, in the red, more extreme hotspots of droughts, and in the blue, weaker hotspots of drought. You can see we can click on a particular point, which you can see in black here, and track the time series of droughts. This is looking at PDSI, which is a drought index over time on the left. And then what we're also able to do is actually get down to the local scale in our global drought hotspot app. So you can see kind of before and after imagery in this decline of Lake Mead, where on the left it's before 1998 and on the right is 2019. So you can see how these environmental trends at the global scale are kind of playing out locally, and more tangibly understand at the visual level how these sorts of patterns and global trends actually play out. So moving on to our next app here, we know, using this textbook quote, that there have been about 1.2 trillion tons of ice melt in the Arctic and Antarctic over the last 10 years. So I translated this particular quote to this local ice melt hotspot app. So here again, it's another before and after app where you can look at southern Greenland. These particular glaciers are seeing before and after imagery from 1999 to 2019. And so again, kind of more tangibly seeing what ice melt actually looks like beyond the statistics here. Our next quote, today the most urbanized regions include Northern America, Latin America, and the Caribbean, with Europe and Oceania following close behind. So again, just using these kinds of numerical statistics, we're not able to actually tangibly understand which regions within Northern America and Latin America and the Caribbean are urbanizing to the most extreme degree, and how do we actually monitor these locations and cities in the future. So this app was translated into an urbanization-focused app. So using this Urbanization Explorer, users are able to actually use night lights imagery from 1995 all the way to the present day to see how these sorts of trends are impacting cities like Shanghai. As you can see, the changes in light intensity here all the way up to 2012. What you're also able to do in this particular app is click on a point on the map and generate a plot to document changes in light intensity over time. So here you can see at that particular point, you can actually export a chart that shows these trends and then download a CSV file that enables students and the public to actually monitor those trends in something like Excel or another monitoring program. For our next quote, we see that extreme weather and climatic events have increased in recent decades, and new and stronger evidence confirms that some of these increases are related to human activities. So again, we're kind of not really able to understand how these extreme weather and climatic events are actually impacting human activities and infrastructure over the last couple decades, and the extent to which those storms are increasing. So this quote gave rise to an extreme weather or hurricane-based app, where you can see each one of these hurricane tracks from almost 1900 all the way up to the present day. So here you can kind of scroll back to 1946, and then you can see on the slider on the left, moving forward all the way up to 1985, seeing those hurricane tracks with their intensities and the colors all the way up to 2017. And what you're also able to do is actually click on points within these hurricane tracks to monitor the intensity of these hurricanes over time and better understand how the intensity has changed in specific locations and maybe even gone down in others. And again, you're able to actually export these data as CSVs for your own analyses as well. What we're also able to do with hurricanes is again look at these sorts of local scale before and after images. So here you're seeing a hotspot location in Dismal Key in Florida. So you're able to see before and after in 2017 with Hurricane Irma. So looking at the extent to which the hurricane impacted the local mangrove forests throughout this region. We're also able to look at other hotspots across the world. So here you're looking at the impact of a particular typhoon in this hotspot in Japan. So you can kind of pay close attention to the extent of the lights that you're seeing in the city here. So you can see it's lighter and now it's darker after the typhoon actually hits this particular location. And again, this is all Landsat based. So again, just using all the data sets that are already provided within Google Earth Engine. So for our final long-term hotspot app here, we see that global sea surface temperatures are expected to rise by up to 4 degrees Celsius by 2100. So with this app, what this quote really translates to is an app looking at sea surface temperature change over time. Here, I just have a static image here, so it's a little bit clearer. But you can see here, again, as with all of our other apps, we have kind of long-term changes displayed on the global scale, but you can also click on a particular point here. You can see just in the ocean in the middle of the Atlantic, seeing the extent of sea surface temperature change over time from 2000 all the way up to the present day, as you can see in this graph on the left. So our latest kind of category of apps that we've been focusing on in particular is more local hotspot current event related apps. And so far we have focused these apps in really 3 different categories. So Australian fires, Amazon fires, and also recent floods in Brazil. So just to give a really quick overview of a couple examples of these apps that we've worked on in the past. Here in this video, you're looking at the extent of Amazon fires from 2005 all the way up to 2019. And what we're able to do here is overlay the extent of these fires with deforestation extents in blue from 2000 to 2019. And so what we're able to do here is really demonstrate that the underlying cause of many of these fires were patterns in deforestation over the last 2 decades or so. And it was really that deforestation that drove the intense destroying of forests throughout the Amazon, as you can see throughout all of these different timestamps with the August fires over the last 2 decades or so. So moving on to our next hotspot app, we can see the same sorts of patterns elsewhere in the world as we see in Australia here. So here you're able to see the extent of this particular drought index from 2000 all the way to 2019. And then what we're able to do is overlay that with other kinds of drought indices. And then in addition, also fire extent data that shows the extent of these different fires all the way on a yearly basis from 2000 all the way up to 2020 to see how the extent of these fires has changed in intensity and frequency and also extent over time. So moving on to kind of future plans in terms of where we're going with this Clouds of Classroom project and satellite imagery analysis. One of our main priorities moving forward will be the expansion of these sorts of real-time climatic events applications. So looking at things like forest fires and also things like hurricanes and droughts, I think is quite critical to, again, translating these sorts of headlines and statistics that you're seeing in the news to actual tangible visible analyses of the extent to which these different climatic events are impacting different populations around the world. What we're also interested in doing is integrating other Google Earth outreach tools. So I'll show you a little bit later when we go into our Google Earth demonstrations, other tools like Google Earth Voyager. You can think of Earth Voyager as kind of the front page of Google Earth. It's where we're able to kind of visually see these different stories, like stories created by different institutions across the world on indigenous lands in Brazil, and looking at more of the human side of things, as well as other example stories, like the one you see on the right in the Canadian Arctic, where we're seeing the extent to which Arctic ice melt has impacted different indigenous communities across the world. So what in the end we're interested in doing is actually integrating these different Voyager-based stories with these different satellite-based apps that we looked at before to create a kind of more complete picture on both the ecological side and also the human side. What we're also interested in doing is integrating a field data collection component into these different satellite-based apps. So using tools like Open Data Kit and Globe Observer, we want users, so students and educators and the public, to be able to actually collect their own data on different factors like precipitation and temperature change, and then integrate those data sets into these different Earth Engine-based apps to really demonstrate how these trends are applicable not only at the global scale and in different hotspots, but also in users' communities. So what I now want to go into is kind of a lead up to an activity that I would be really interested to see kind of all of your thoughts, and I'll end up putting you in breakout rooms to actually start to play around with a couple of these tools. But the first tool outside of Earth Engine and these different apps that I want to show is Google Earth Timelapse. So I will open up that particular tool. So great. So this is Google Earth Timelapse. It's a global zoomable video of different changes that you're able to see using Landsat imagery across the world. So here you're able to see, just using this first hotspot here, the extent of glacier retreat again in this particular hotspot, the Columbia Glacier in Alaska. And what you're able to do is kind of scroll through all of these different hotspots of global environmental change to understand how climate change is actually impacting these different regions around the world. And so I think one of my favorite examples is actually this particular hotspot in Dubai, where we're able to really document coastal expansion using satellite imagery. So zooming in here, hopefully the video will load. And here you can see over time the growth of these different man-made islands as they expand around Dubai. So really this is the purpose of time-lapse in general, to actually document these different hotspots of environmental change and human-caused change directly, like these examples of urbanization, and see how we can see these different patterns like mining or like deforestation, not only in local communities, but also elsewhere across the world. So moving back to the presentation. So the project that I would be interested with all of you completing is kind of an intro to Google Earth time-lapse and to using satellite imagery to global environmental change. So if, using time-lapse, you could pick any 5 hotspots to prove or explain climate change to the public, then which would you pick? So considering things like the extent of the change that you're seeing, or more well-known versus more obscure examples. So while something like Amazon deforestation might be well-known, maybe it is, in your eyes, one of the best examples of showing how humans are impacting the climate crisis around the world, versus more obscure examples, like a particular example of ice melt or agricultural change that people might not know about. And then also consider kind of a variety of climate impacts in different regions across the world. So showing that climate change isn't just relevant to certain communities, but rather it's relevant really across the world in your local community as well. So how exactly am I going to have all of these groups present these different kind of rankings of the most critical different environmental hotspots? Well, the answer is a program called Google Earth Tour Builder. So here you can access Google Earth in Chrome. It's a new project where you're able to actually see Google Earth online, not just kind of download it to your desktop by going to google.com/earth. What you can do from there is actually launch the Google Earth program, and hopefully it will load in a minute. And here what I'll show you as well is the Voyager program that I referenced before. Hopefully it will load. Okay, perfect. So when I open Google Earth, this is the first thing I see. This is actually where I'm at right now. I'm at Stanford University out in California. And so the tool that I'm interested in demonstrating here is, again, Google Earth Tour Builder. So you can see kind of these icons all the way on the left. If you click on this 4th one down, you can see a projects tab. And this projects tab enables you to create your own tours anywhere in the world. And I'll just do kind of a quick demonstration of what creating a tour might look like. So you can start out by clicking new projects. You can start new projects just within your Google Drive account, as long as you have Google accounts. We can call this sample project ICN Summit. You can add a description of the project as well. And then what you're able to do is start actually adding features to the globe. So if you want to create a new place mark to put on your map, you can add a place mark and select a location wherever you are to start out. So I'll just put it in the middle of Stanford right here. You can title your particular place mark, whatever you like, and then you add to the project that you're working on now and save it. What you're then able to do is actually add media as well. So if you click Edit Feature, then you're able to see all of these other tools here. So you can add things like pictures or video or a description, or even do things like change the place mark that you're looking at. You can also do slightly more complicated changes to your Google tour by changing things like the latitude or longitude or altitude where your place mark is, but that's obviously optional as well. So what you're then able to do is zoom out, and then anywhere in the world where you're interested in placing a benchmark, you can just do what I demonstrated before in terms of, placing the mark using the Google Tour Builder. So zooming out here, my world is upside down. Let's move it to the right direction. So you can see here. So let's say the next location that I'm interested in marking on the map is Washington, DC. So I can add a new feature, and if you're interested in a particular location, you can search the location here. So I just searched Washington, and you can find the capital of the US. And what the tour builder enables you to do is actually zoom in, and then you can add that particular place mark to your project and save it as another location here. So it's zooming back out again. And then the third location, the third kind of feature that I'm interested in documenting is a feature that enables you to actually do things like drawing lines or shapes throughout your project. So say you wanted to actually draw a line from Stanford all the way to DC. So you can start a place mark here and then end it here. Press enter to save it. And then we can just call it path, for example, and save that. And what you're also able to do is actually drag and drop the location of these different aspects of your Google tour to create a more complete presentation. So perfect. Now what we're actually able to do is present this tour. So if you click present here, then you can start in your first location. Here you can see we're starting all the way at Stanford, which is where my first icon was. If you click next in the table of contents here, you can go up and zoom all the way out to our second landmark. So looking now to Washington, DC, our line, and then finally zooming in. So that's all. It's pretty simple creating these actual tours. And so what I'm interested in having you do for this particular project that I'll be putting you in breakout rooms for is using Timelapse, which is the tool that I showed you before, to actually, and I'll post the links in the chat as well, to actually select your top 5 hotspots of environmental change. 5 hotspots meaning, again, those that you found to be most compelling examples of how to actually prove or explain climate change to the public. And then what I'll have you do is actually create a tour within the Google Tour Builder, within Google Earth, to actually present these different hotspots to the audience of this workshop. So I'll put you in breakout rooms for about 25 minutes, and then each group will work together on coming up with their 5 different global change hotspots, and then using the Google Earth Tour Creator tools to actually showcase all of those hotspots that you chose. And definitely consider, doing things like adding pictures or videos and descriptions to each location using that Edit Place Marks tool, or doing things like including news articles or statistics to give a more complete picture of the changes that we're seeing. So I will open breakout rooms in a minute. A couple steps once you're actually in your breakout rooms. I would love if you could start out everyone by introducing yourself, explaining where you are. It's just a really quick bio in terms of what actually brings you here and to the session in general. And then end by just describing kind of your favorite place in the world. And then your next step is, of course, collaborating on selecting your top 5 hotspots of environmental change. And then finally creating a Google Earth tour actually showcasing these hotspots of change. So perfect. I will start by putting the links to these different tools in the chat. So this is the link to Google Earth in Chrome. And then the time-lapse link, I will copy and paste. Perfect. So you can use this time-lapse link to find your top 5 locations of environmental change. And then again, you can use the Google Earth link to actually find, to actually present these different locations. So perfect. I will work on creating breakout rooms in a minute. Okay, perfect. Hi, everyone. I hope that activity went well for all of your groups, and I'm really excited to hear what everyone came up with. So I guess I'll just start. I'll try and get through as many groups as I can and who want to present. And so I guess I'll just start by calling on maybe Breakout Room 3. Is anyone interested in presenting from Breakout Room 3? No. Okay. It could potentially be hard to keep track of which breakout rooms were active or not. So I guess we could do it the other way around. I would love if there could potentially be a volunteer from any one of the breakout rooms who's interested in sharing what they came up with and sharing their screen.
We only add places to the project.
Could you repeat that one more time? I think you broke up.
Yeah, we our breakout room only added 4 places to the project we made on Google Earth.
Okay. No problem at all. That's no problem. Do you want to share your screen to show your project, or at least describe it?
Yeah, just give me a moment. Honestly, I don't know if we did it correctly.
No worries at all. Anything is fine.
So there, I'm sharing. You can see it in my screen?
Yes, exactly.
Okay, so we added Texas, considering that there was a cool front in all this area and in the north of Mexico, and it caused some struggles, and a lot of flora was lost due to it. We also put the Great Coral Reef in Australia, the Arctic, because of the permafrost loss, and finally we put the Florida City because of the floods that occurred there due to the loss of the ice in the Antarctic.
That sounds awesome. Thank you so much for sharing. No, this was great, and a really wide variety of different types of hotspots too, which is really important.
I stopped sharing now. Or
Yeah, sure. That sounds great. Okay, great. Do we have another volunteer who wants to share their project?
Yeah, I would like to share. May I?
Yes, definitely. Go ahead.
Yeah, can you hear me?
Yes, I can.
Yeah. So basically, I have included 5 metropolitan cities. No, I have only done 4 because time is less. So 3 are the metropolitan cities, and 1 is the Western Ghats, which is highly affected by the climate change. So here I go. So this is the first place, the first metropolitan city, which is Mumbai itself, where I belong to. this is Mumbai. Yeah, so this is Mumbai, first place. Then second is the Western Ghats here, which is location is I wasn't able to trace it to the very perfect location. And then second goes with the Tokyo. And then the fourth one, which I tried to connect, was the Canada. Actually, it started from Canada and then it ended to Tokyo.
Okay,
Yeah,
perfect.
so this is the project which I tried. Yeah, thank you.
Thank you so much for sharing. I really appreciate it. And that was great. And even more importantly, all different spots from the last presentation. So a lot of different options for that. And I just saw in the chat, for those who joined late, just for a quick recap of what the project was, participants were asked to find the top 5 hotspots around the world that they thought kind of communicated climate change or communicated environmental change in a way that was most dramatic or most kind of easiest to understand to broad audiences or the public. So, you know, if you were trying to explain what global environmental change means to just the average person, these were the 5 hotspots around the world that you thought might do that best. And then participants used Google Earth Tour Builder, which you can access just at the online Chrome version of Google Earth, to build a tour kind of showcasing each one of those places using Google Earth tools. So awesome. Do we have another volunteer for who wants to share the project?
I can share my groups. So I was in a lovely group with Haley, Gab, and Teresa. And so I can share my screen quickly. Oh, sorry, 1 second. All right. So our first location that we had was the west coast of Antarctica. We chose this because the west coast is really known for indicating areas of ice melt and loss of mass. Our next spot was Ho Chi Minh City, and this is because it is in a delta region, and so sea level change will be a real impact in this area over the next couple of years. We also indicated Venice City as well. This is also in a delta, and they are also experiencing areas of increased sea level, and it's impacting the city a lot in both of these areas. The next area that we chose was a little bit larger, and that is the entirety of the Sahara Desert. So desertification is a really big thing that's happening. There's a reduction of rainfall happening along the borders of deserts, which is actually causing kind of an increase of deserts over time and a decrease of vegetation in these areas. And our last place that we chose, which is really interesting, is Lake Chad. And this shows how unsustainable use of the land by government and communities has resulted in the lake to pretty much disappear over time, as well as how the flora and fauna of this area is disappearing quite rapidly because of that. So that was what my group put together.
That was fantastic. Thank you very much for sharing. And again, all different hotspots, which is great. And I particularly like the sea level rise ones too, especially in Vietnam. Those are quite critical now. So great. Any other groups that are interested in sharing? Okay, perfect. From there, I'll just go back to one last slide of the PowerPoint with my contact information, and then I can turn it over to questions if anyone has any. Great. So thank you very much for the opportunity for me to share all of these projects with you and other ways of using satellite imagery to monitor global environmental change. And I would really encourage you just to reach out. This is my email that you're happy to reach out to for different collaboration opportunities or also training opportunities, whether you're interested in training your institution or maybe you're affiliated with a particular school to encourage training both in person or online, depending on your needs with COVID or otherwise. So thank you very much, and I will stop sharing and turn it over to questions now. I saw one participant raise their hand. Just go ahead and ask your question.
Hi, my name is Carrie. This is all really fascinating work and good job. It's all laid out really well, and it's incredible the amount of data you've compiled into this work. I did want to ask, you mentioned you had different curriculums built. Do the curriculums, are they based upon the community that you're educating? My organization does a lot of work with Indigenous communities, and it's very prevalent that the Indigenous communities have a very different experience of climate change, and their awareness of it is much different than those in other areas. So are those curriculums built around those different communities, or are they built around something else?
Yeah, that's a really great question, and it's a big gap actually so far in this project. So far, in order to create the curriculums, we've really just been able to collaborate with teachers in the US and Europe, which is obviously completely not representative of many of the communities that we want to reach out to across the world. So I would absolutely love to follow up with you and love to hear your thoughts in terms of how we can get the opinions and the needs of Indigenous communities and some of the populations that you work with.
Hi, can I ask something as well?
Sure, of course.
My name is Elua, and I work as a consultant for businesses. And I guess the ecosystems and land doesn't really care about who is the responsible of the impact of the change. But I wonder if with the technology and the latest developments, is there any project trying to not finger point the responsibles, but trying to support as well sectors, economic sectors to join initiatives and as a joint group and trying to fight against the, I don't know, pollution in the water, or hotspots for CO2 emissions. I don't know. Have you heard anything about that?
Yeah, that's another great question. So far, most of our collaboration with these particular apps has been more on the conservation side. So we haven't been able to work with industry thus far to kind of document the impact of different companies on issues like pollution or their impacts on different ecosystems. We have done it more sort of based on the other side, so working with organizations like World Wildlife Fund or Conservation International to kind of document on the global scale impacts on different ecosystems. But kind of starting to go more on the private sector side or more on the industry side, I think is really critical to try and bridge those gaps between what we're seeing ecologically and the needs of different companies. So definitely reach out. I'd love to speak more on this in terms of how we can incorporate other companies and other institutions to further our analysis on that end. Any other questions? I see another participant is raising his hand.
Thank you, Liza. I'm starting my thesis. Sorry, let me just say that I'm doing my MSc in climate change and development, and I'll be conducting my thesis on next semester on the climate. Am I audible? Am I audible, Lisa?
Sorry, you broke up for a second. Could you repeat that one more time?
Okay, am I audible now?
Yes, I can.
Okay.
I can hear you.
Apologies. I'm doing my MSc on climate change and development in University of Bangladesh.
Mhm.
So I'm actually seeking advice from you. I'm doing my thesis on climate and urbanization and urban resilience. So we're sort of trying to put on some work on modeling, especially climate policy and the RCPs that you have already said in the if I'm not wrong, it's mentioned in AR5 or 4. No, the report. So what are the main factors we should consider in terms of modeling and especially putting in them in the map, and the trend we are trying to in terms of the heat signature, the heat map and the rain map. So what are the main factors we should consider in terms of putting in to the position of urban resilience, like how it's affecting urban resilience? Am I?
Sure. Yeah, that's a good question. So I would start by taking a look at a lot of sample scripts within Google Earth Engine. So what the Earth Engine team has compiled are a lot of scripts in terms of how to kind of harmonize different temperature and climate data sets and kind of integrate them with different representative concentration pathway or RCP scenarios. So I think a great kind of starting point with the project, at least how I understand it, would be starting with kind of the most simple climate change indicators, so precipitation and temperature, to kind of see how those indicators are changing over time and how they have been since going back to kind of the beginning of those data sets, so starting in 1950. And then once you can kind of create a harmonized model of how those changes are happening over time in your particular region. At that point, you can move forward with your understanding of how that region has been alternatively resilient or has been impacted negatively to those types of changes. So I think starting with that kind of long-term historical analysis or time series change is really important to kind of just contextualize where you are geographically in terms of adaptation to climate change.
Thank you so much.
Of course. Any other questions? And I see a request for my email in the chat. I will put, this is my primary email. And then I will also put the website to the Classic Classroom project here too. Perfect. So any final questions?
I have a question, if I may. Sorry, I cannot raise my hand on the browser version. So I'm currently a student in environmental biology at the University of Toronto. And one tool that we have to take a course to learn how to use is Arcgis, which is a geographic information system that is used to make maps. And so I was wondering if there's any form of not compatibility, but whether we can use any of the data that is available on Google Earth Engine to make maps or other models that we would use ArcGIS for.
Yeah, that's a great question. So I think that the tools are actually quite compatible, despite what the Google team would say. So I think probably the easiest flow of work between Google Earth Engine and ArcGIS would be if you find a data set within the Google Earth Engine catalog that you're interested in looking at. What you can do is actually export that data set from Earth Engine. I can, if you follow up with me, I can send you some sample scripts, or just I encourage you to check out the developers tools website for Google Earth Engine. I can send that in the chat as well. And so they'll tell you just kind of how to export a particular data set over either the entire world, or you can also do just a specific hotspot location. And then what you can do is, you export it as like a shapefile or a TIFF or something else like that. And then you can upload that data set to ArcGIS if you're more interested in doing the analysis within ArcGIS as well.
All right. Well, thank you for your answer, and thank you very much for your presentation today.
Of course. Thank you. And I will send the link to the Earth Engine developers list in the chat as well, the API. Okay, perfect. So in the link I just sent, that's where you'll be able to find like an introduction to Google Earth Engine if you're interested in coding on the back end, and also learn how to do things like exporting data, like I just mentioned. So perfect. Any more questions? Okay, great. Well, thank you very much, everyone, for coming to the session. It was great to meet many of you, and thank you for your presentations as well. I definitely encourage you to check out the Cloud2 Classroom website and reach out if you're interested at all in collaboration or training. So thanks very much, and hope everyone has a great rest of the summit.
Thank you so much. Bye.
Thank you.
Bye.
Thank you very
Thank
much.
you. Shubhratri.
Thank you.
Thank you so much. Bye-bye.
Thank you.
Thanks, Lisa. So I think we can, yeah, turn off it, right?
Okay,
Maybe
yeah, I think so.
we'll have few people there, but yes, we can finish it now. Okay, thank you. Yep.
Perfect. All right,
Bye.
bye.
Okay, goodbye.